Welcome again. We discuss about the regarding the thresher. The following factors affecting the threshing efficiency are peripheral speed of the cylinder concave clearance, type of the crop, moisture content of the crop, weather condition, and feed rate. You know the recommended speed of the threshing drum for paddy speed drum is 675 to 1000 rpm, or in meter 60 to 25 meter per second. With in rpm that is near about 550 to 1100, and in meter per second 20 to 30 meter per second. Now barley again 740 to 1000 rpm, and in meter per second 20 to 26. Gram 400 to 750 rpm, and in meter per second 12 to 22. For jawar, the speed of the drum recommended speed is 400 to 675 in rpm, and in meter per second 12 to 20. For bajra 400 to 550, and in 12 to 60 meter per second. For peas it is 430 to 750 rpm, and 12 to 22 meter per second. This is recommended speed for the threshing drums. That speed it get the satisfied threshing operation. Now precautions and care in operations of thresher. The machine should be installed at a level surface as far as possible. Second, the direction of the machine should be set in the direction of the prevailing wind, and thresher should be operated at the speed recommended by the manufacturer. And suitable size of pulley should be provided on the thresher to operate the cylinder at a recommended speed. Therefore, feeding should be continuous and uniform. Bearing and other working parts should always be properly greased and oiled. While feeding, the care to be taken. The crop should be free from any wooden or iron pieces, and it is desirable to dry the crop before feeding as far as possible. 10. The sieve should be inspected frequently and cleaned from the time to time to avoid a clogging. And while feeding, the operator should not insert this hand deep in the feeding trough. After the continuous working for 8 to 10 hours, the machine should be given some rest before it is put into the operation again. After threshing season, all the belts should be removed and machine should be kept in a covered place. Now the terminology related to the connected with the power thresher. Clean grain, it is the thresh grain free from the foreign matter and broken grain. Cleaning efficiency, it is a clean grain received at a main grain outlet with respect to the total grain mixture received at main grain outlet, expressed as the percentage by the mass. Concave clearance, it is the clearance between the bitter or cylinder tip and the concave, and feed rate, it is the quantity of the crop fed into the inlet of the thresher per unit time. Now the threshing efficiency, or the thresh grain received from all the outlet with respect to the total grain or input, expressed as percentage by the mass. Blower loss, it is also the percentage of the grain blown by the blower along with the busa with respect to the total grain input in thresher by weight is called the blower loss. Sieve loss, the percentage of the healthy grain dropped from the sieve with respect to the healthy grains received from main outlet by weight is known as the sieve loss. And cylinder loss is the percentage of unthreshed grains from the outlet with respect to the total grain input in the thresher by the weight is called as the cylinder loss. Winnowing is the process of separating the grain from the mixture of grain chaff, and other impurities in an airstream from the natural or artificial sources. Before the winnowing is started, the threshing floor is thoroughly clean and sometimes plastered with the cow dung so that soil may not be mixed with the grain. What are the principle of winnowing? There is a separation is achieved by the allowing the airstream to pass through the mixture and falling vertically down, and density difference of the component of mixture, namely heavier grains, lighter chaff, and busa is responsible for the separation when suspected grain is an airstream. And the grain being the heavier material gets the deposited almost at the place of the dropping, where the lighter material is blown away to the greater distance. Winnowing devices are commonly adopted. The winnowing processor, the winnowing basket, winnowing fans, and winnowers. Now, winnowing basket used for winning basket, oldest and common method of the winnowing in India. It makes the natural wind, which is very frequent and effectively at the time of the harvesting. And keeping this hand up and continuously stirring the basket very slowly, and he drops the grain. As the grain falls, the broken straw, chaff being lighter than the seeds, are taken at the far distance by the blowing wind. The grain being heavier than the straw and falls the very near at the platform. Thus the two heaps are formed, one of the grain and other of the straw, which are collected separately. Now the winnowing pan, where the natural wind velocity is not adequate, the artificial means are used to create the sufficient strong air blast. Winnowing fans, either manually operated or mechanically operated, are mostly used, and manually operated fans of the various types are available for the use in India. Most often the hand operated or parallel operated winnowing fans are used by the farmers. In either case, the fan blades create a steady blast of the air at the front side of the fan. There is a various types of hand operated and pedal operated winnowing fans are manufactured by many firms in India. The numbers of blades on their impeller is either 3 or 4. And the diameter of the impeller varies from zero point 0.9 to 1.25 meter. Mostly the blades are made up of the mild steel sheet, and their frames are made of the either wood or welded steel or a combination of the two. In order to increase the rotational speed, various driving mechanisms are employed, namely sprocket and chain drive, V-belt pulleys, single or double reduction gears. All these fans are without casing around the impeller, and they are expressed to be operated in the speed of 200 to 350 rpm. This is the winnowing fan. Now the winnowers consist of the wooden or angle iron frame housing, blower, feed hopper, feed and purity adjustment mechanism, grain outlets, immature grain outlet, chaff and dust outlet, and blower hand wheel with the gears and pulley arrangement. Wall of the feed hopper tapers toward the inside from all the sides and ensure the gravity flow. Flow of the mixture is regulated by the feed rate and adjustment mechanism, which makes the mixture to fall the thin stream perpendicular to the air current, and is essentially a gate obstructed the flow below the feed hopper. Therefore, the blower consists of the four curved blades mounted horizontal on a shaft with two ball bearings. The sieve is placed in front of the pan at the lower end of the winnower, and the set of the sieve are supplied with a machine to suit the different size of the grain. These sieves have holes 12, 8, 6, 4, 3 and 2 diameter. The sieve is reciprocated by the eccentric roller which gets its motion from the axle of the blower. The reciprocating action of the sieve permits the grain and dirt particles to fall down while the straw is blown out. Now working of the manure is the mixture of fall into the air current and the lighter material and chaff are blown through the opening for chaff and husk outlet by the air blast, while the good grains being heavier fall directly below the guided out by the grains. And proper RPM of the blowers and feed rate are essential for efficient winnowing of the grains from the other lighter fraction. Now the groundnut decorticator, the process of obtaining the kernel from the ground pods is known as the decortication. And mostly decortication is usually done by breaking the shell by hand pressure under the thumb. And manual decorticator by hand is laborious, expensive, and less productive. But now the commercial hand and power operated groundnut decorticator are being used in the country, and both these machines work on the same principle, and the main difference lies in their capabilities. After decortication, separation of the grain from the mixture of grain and spilled shell is done in an air stream. The hand operated one has a capacity about 200 kg per hour,